If you haven't done so yet, please pause the video and attempt to solve the question on your own before listening on. Since the string is fixed at both ends, we know that the resonant frequencies can be represented by the following equation. For the speed of the wave on the string, we know the following equation also holds. We have the square root of the tension in the string divided by the linear density of the string, which is indeed what we're looking for. Now, since the string is attached to this mass, and the mass is in equilibrium, we know that the tension in the string would equal the gravitational force that's acting on the block. So we can actually substitute mg in for this tension. We'll now go ahead and substitute this expression in for the speed of the wave on the string. And this equation would hold for integer values of n from 1 on to infinity. We're going to actually go ahead and solve this equation for the mass m. So we'll have to square both sides of the equation. We could then multiply both sides by 4L squared mu. And then finally divide both sides by n squared g. Now, if we study this equation carefully, we can see that the mass is inversely proportional to the harmonic number squared. For example, if the 447 gram mass corresponds to harmonic number n, then we can write the following proportionality. Remember, it's inversely proportional to the harmonic number squared. Well, then in that case, the mass of 286.1 grams would be inversely proportional to 1 over the next harmonic number squared. We can actually divide these two proportions. Just note that on the right side, you're dividing two fractions essentially. And so this algebraically will actually move to the numerator here. We'll go ahead and square out the numerator. We'll then rewrite this fraction in the following manner. Notice that n squared over n squared becomes just 1. We'll then subtract 1 from both sides of the equation. And then we can pick up our calculators and simplify this. Finally, we will multiply both sides of the equation by n squared. So basically what you need to do is multiply 0.5624 by one of these perfect squares until you get an odd result. And it turns out that when you multiply by 16, that is, when you multiply this quantity by 16, you indeed get roughly an odd integer. You get something like 8.994, which is pretty darn close to 9 in odd integer. So that means our perfect square is 16, which means our n is 4. So we just want to make the conclusion that n is equal to 4. We can recall this equation that we had developed earlier, and what we want to do now is solve it for mu so that we can calculate the linear density. So we'll multiply both sides by n squared g, and then divide both sides by this term right here. And now we could just plug in the known values. We know the mass is 447 grams. We'll have to convert that to kilograms. N, we concluded, was 4. G is 9.8. The length was given to us in the question, as was the frequency of 120 hertz. So we'll go ahead and plug in all those known values. And when you simplify that, you should get approximately 8.45 times 10 to the minus 4 kilograms per meter. If you wanted to convert that into grams per meter, you could just multiply this by 1,000. And that would give you a value of 0.845 grams per meter, which is indeed the correct answer. Note that you could have also used this value for the mass m, so long as you used a harmonic number of 5, because remember, this mass corresponded to a harmonic number of n plus 1. So if you wanted to, you could plug in 5 for n in the equation, and then for the mass, you just have to substitute the 0.2861 kilograms. Thanks for taking the time to watch the video. If you liked it, please click the thumbs up icon and subscribe to the channel. Also, you can send in your own question to this email address, and I'll do my best to post a solution to it on YouTube.